Alright, so now we're going to talk about valence electrons. Now, valence electrons are the outermost electrons that you can find in an atom. Alright, that's the basic idea. So valence electrons, they are simply just the outermost electrons. They're the things that are the furthest out there. When you have an atom come into contact with another atom, valence electrons are the things that interact. They're the things that determine whether something bonds, whether something, like if they combine together, just all of that. All right, that's what a valence electron is. And they're kind of important. They're the things that are in the outermost energy level, and they're what control bonding. So just to look really fast here, if you look at valence electrons, the definition and like some examples here, thankfully valence electrons, like the idea behind them, it's really, really, really simple. So pretty much all you're going to be doing here is looking at like elements and saying like, how many valence electrons do they have in their outermost energy level? Okay, and thankfully the way we can sort of do that is by just doing this. So periodic table. Well, actually, first let's just look at some examples before we do that. So if you look at examples here, valence electrons, it's the highest S and P sublevel, right? So like, look at something like fluorine. All right, how many valence electrons does fluorine have? Well, the highest S and P sublevel is 2s2p. Fluorine has 7 valence electrons because in the second energy level there's 7 electrons. Potassium, what's the highest S or S and P sublevel? Well, here you have something in 4s. That's the only thing in 4. It's the highest S. Potassium has 1 valence electron. All right, 1, etc. Now, something like iron on the other hand here, this one's a little confusing. It's the highest S and P sublevel. Okay, so again, we might even want to write that down officially. So valence electrons are the highest S or S and P sublevel. So in the case of something like iron, the highest sublevel that we have present here is 3D. But that's not an S or a P. So instead, let's go back. So 4S is actually the highest sublevel that we have, the highest S or S and P. There is no 4P. And we're not going to go back down to 3P. We're just going to stick with whatever's in the highest energy level here. So in this case, we've got 4S. It's got 2. So in this case, iron only has 2 valence electrons. These other ones, they don't count because you notice they're in the 3rd energy level, not the 4th energy level. All right, that's the difference. All right, that's the big difference there. So just to show you a little more here. So if you take a look at this here, this is another example. Valence electrons, they're the highest energy electrons. In an example like this, you have germanium, and you can see that you can just ignore the 3D. All right, that's the deal. Now, something with valence electrons that it's really good to remember, it's really easy to figure out. You're pretty much just going to be looking at the periodic table. All right. So this little thing it shows you, but it's directly on the periodic table. What do I mean by that? Well, here's what I mean. So if you look at the periodic table here, you pretty much are going to see that the groups are numbered 1, 2, and then 3, 4, 5. Excuse me. Excuse me again. 6, 7, 8. They're numbered. And that's cool. So the simplest way to identify valence electrons is everything in this first column, it's 1 valence electron. Everything in the second column, 2 valence electrons. So like calcium has 2 valence electrons. Magnesium has 2 valence electrons. And if you keep going, the only thing, everything in the D block here in the transition elements in the middle, we just generally say those are 2 valence. That's not always right because sometimes they actually fill up a little differently. There are exceptions to the off-ball principle in the transition elements, but it's not something you need to be concerned with. But just know that this whole middle group is 2. Then you go to 3, 4, 5, 6, 7, and finally 8 valence electrons. Notice the most valence electrons you can have is 8. Notice the noble gases, they all have 8. That's actually the reason they are very stable. They don't have an open spot for their valence electrons to do anything, so they don't really react with anything. They're just there. But that's the deal. That's the basic idea. So like if we said how many valence electrons does like carbon have? You're like 4. What about sulfur? 6. Iodine? 7. I mean, it's just, that's it. It's just that simple. All right. So it's not something you need to be too worried about, but just wanted to make sure that you understood what it was.